Good morning friends, welcome back to Parnika tutorials. In the last video, I have discussed what is a critical session, what is a race condition, then primary and secondary requirements of any process synchronization mechanism. I hope you have watched that video. If you did not watch that video or if you don't know the concepts such as mutual exclusion, progress, bounded weight, I request you to go back and watch that video and come back to this video. In this video, I want to discuss one of the process synchronization mechanism which is a lock variable in detail. So I request everyone to watch the complete video for better understanding. First, let me discuss few important points related to the lock variable. Then I will discuss the working process and its limitations. Now, the lock variable is a software mechanism. And then we have two modes. One is the kernel mode and another one is user mode. The lock variable works in the user mode. And the process synchronization mechanisms are broadly classified into two types. One is busy waiting and another one is non-busy waiting. First, let me discuss what is a busy waiting. Now, let's consider that you have process P1 and process P2 and you have a critical session. Now, any synchronization mechanism should provide the mutual exclusion. What is meant by mutual exclusion? At any time, maximum one process can be there in the critical session. Okay, now let's consider that process P1 is there in the critical session. Now process P2 wants to enter into the critical session. Now process P2 will verify whether critical session is occupied or vacant. Whether critical session is occupied or vacant, it is occupied. Okay, now if it is occupied, process P2 again will search whether it is occupied or vacant. Again it will check. So process P2 will not do any other work. Instead of that one, it is keep on verifying whether critical session is occupied or not. Am I right or wrong? So this kind of solutions we'll call it as busy waiting solutions. And then we have non-busy waiting solutions where process P2 will not keep on verifying whether critical session is occupied or not. Is it clear? So the lock variable comes in the category called busy waiting solutions. And then it is a multi-process solution. So it can work properly for two processes or more than two processes also. So this is about the lock variable. Now let me discuss with two processes how the lock variable will work. Initially, lock value will be 0. If the lock value is equal to 0, meaning is that it is vacant. Is it clear? See, we can consider it as either 0 or 1 or false or true, because 0 represents false, 1 represents true. So let me represent using the 0 and 1. So if lock is equal to 0, meaning is that it is vacant. Which is vacant? Critical section is vacant. If lock is equal to 1, then critical session is occupied. Is it clear? Are you able to understand? So initially lock value is equal to 0. Okay, meaning is that critical session is vacant. Okay, so let me consider a critical session. Now you have a entry session and you have a exit session. Already I have discussed any process synchronization mechanism. Before critical session, you will write a piece of code. After the critical session, you will write a piece of code. This one we'll call it as an entry session and this is an exit session. Now coming to the lock variable, let me discuss the entry session first. While lock not equal to 0, so you have a condition. If you have a condition, the condition can be either true or false. Let me discuss what will happen if the condition is true. If the condition is true, as there is a semicolon, again it will check whether this condition is true or not. If the condition is false, it will come and execute this statement. I hope it is clear for you. Okay, now look at here. Initially lock value is equal to 0 and process P1 wants to enter into the critical session. If process P1 wants to enter the critical session, it needs to execute the entry section. So while lock not equal to 0, what is the lock value? 0. So they are saying 0 not equal to 0, which is false, because 0 is equal to 0. So as this condition is false, it will execute this statement. What is it? Lock value is equal to 1. So initially lock value is equal to 0. Now process P1 has updated it to 1. And then it will enter into the critical session. So process P1 has entered into the critical session. Okay. If it is normal, okay. Now process P2 wants to enter to the critical session. Now again process P2 has to execute the entry session, because if any process want to enter the critical session, first it has to execute the entry session. Okay. Now look at here. While lock not equal to 0, what is the lock value now? Lock value is equal to 1. So 1 not equal to 0. Yes, this condition is true. If this condition is true, again it will verify this condition. So it is in an infinite loop. So it is busy waiting. That's why it is called as busy waiting. It is keep on checking whether lock is not equal to 0 or not. Is it clear? So process P2 is still executing the instruction 1. So it cannot enter the instruction 2 and it cannot enter the critical session. Now let's take that after some time process P1 has completed its critical session and come out from the critical session. So if it come out from the critical session, it will execute the exit session. So what is there? Lock is equal to 0. So again it will update it to lock is equal to 0, and now critical session is vacant. Now process P2 again verify while lock not equal to 0. 0 not equal to 0, the condition is false. Is it clear? If this condition is false, now it can make lock is equal to 1 and enters to the critical session. Is it clear? Are you able to understand? The solution is very simple. Okay, you have a door. Okay, on the door you have small paper. Okay, in hotels you can see it, am I right? On the lock they will keep something busy and occupied and vacant, like that, am I right? So they will keep it as occupied or vacant. It is not like a lock, it is like a tag. If I want to enter, if it is their tag called occupied, I will not enter into that room. If it is written as vacant, then I can enter it. It is clear? So once let's take that it is vacant. Okay, it is written as a tag called vacant. Now a person P1 has verified it is a vacant, then he will go inside and he will keep a tag called occupied. So if any person want to enter, it will display as occupied, they will not enter. So the same way it will work. Now let me discuss. You may think that, sir, it is providing mutual exclusion. How? At a time only one process is entering into the critical session. Okay, but always it is not correct. Why it is not correct, I will discuss with an example. Okay, is it clear? To do that one, let me discuss with step numbers. This is step 1, step 2, or instruction 1, instruction 2, this is 3 and this is 4. Now you have a critical session. Okay, and you have process P1 and process P2. The same example you can expand to any number of process. Okay, now initially lock value is equal to 0. Now process P1 wants to enter into the critical session, so it has to execute the entry session. So it will first execute the instruction 1 while lock not equal to 0. Now lock value is 0. So 0 not equal to 0. So this condition is false. If this condition is false, it can execute the second instruction. While it is executing the second instruction, it was preempted. Is it clear? Are you able to understand? If it is preempted, then process P2 is verifying it. Is it clear? Process P2 is now want to enter into the critical session. Are you able to understand? While the process P1 has completed the instruction 1 and want to execute the instruction 2, it was preempted. Okay, now process P2 entered to the running state and it wants to enter into the critical session. So again it will execute the entry session. Now what is the lock value? Still lock value is equal to 0. So this condition will be false. So now process P1 has completed executing the instruction 1 and it is executed the instruction 2. Now what is the lock value now? Lock value will be 1, and who has updated it? Process P2 has updated it. Is it clear? Now process P2 entered into the critical session. Okay, now process P2 is there in the critical session. Now process P1, okay, wants to execute or enter into the critical session as it is completed the instruction 1. Are you able to understand? It will not again execute the instruction 1 because each process will have its process control block PCB. Am I right or wrong? PCB will be there. In that one, several attributes will be there. One of the attribute is program counter. The program counter will have the address of the next instruction. As it is executed the instruction 1, the address of the next instruction will be this one. Okay, so again it will update it to lock is equal to 1 and it will enter into the critical session. Now look at here, at a time both the process such as P1 and P2 are there in the critical session. Is it providing mutual exclusion? Mutual exclusion is not provided in a worst scenario. Are you able to understand? Any mechanism or any solution we need to look at in the worst scenario only. In the worst scenario, the lock variable is not providing the mutual exclusion. Is it clear? If it is not providing the mutual exclusion, then it is not correct because any synchronization mechanism should provide mutual exclusion and also progress. These are the two primary requirements. However, lock variable is not working with the mutual exclusion itself, so we will not verify other things. So this is the drawback of the lock variable. I hope you have understood how the lock variable is working and its limitation. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.